this lesson, I will be showing you how to simplify radicals. We will be looking at 4 practice problems, and we will simply just simplify them as much as possible. So let's take a first look at the sample problem, our first sample problem. So we have cube root of 5 plus x to the power of 12. Now, when you're simplifying radicals, when you are presented with a radical, you always want to try to make things easier for yourself. And one way in doing that is to expand out of this radical form. Once you've done that, you can simplify, and then if you want to or have to, you can go back into radical form. But it's much easier to expand it and then simplify and then go back. So let's do just that. Let's expand it. So we have 5 plus x, and 5 plus x whole to the power of 12 would, cube rooted, would just be 5 plus x to the power of 12 by 3. And what we have here is 12 by 3, which is divisible. So we are left with 5 plus x to the power of 4. And that will be the final answer. So that first problem was simple enough. So let's take a look at the second problem. Here we have, once again, another cube root of h to the power of 4 and j to the power of 6. Now we'll do the same thing and where we expand it as much as possible. So this will become h to the power of 4 by 3 and then j to the power of 6 by 3. Now, are any of our exponents divisible? Can it be simplified? And j to the power of 6 by 3 can be. So now we have h to the power of 4 by 3, and then j to the power of 6 divided by 3 is 2. Now, once you got to this point, we can leave it like this, or we can bring it back into radical form. In this case, we should, because we don't want to have a fraction as one of our exponents. If you have a fraction as one of your exponents, try to take it back into radical form. And this would be simple. All you have to do is just take that denominator, and then you just bring it to the outside in a root. So our new answer would be cube root of h to the power of 4, and then on the outside we have j to the power of 2. This would be the final answer. There's no more simplifying after that. Now let's look at our third example. The third example would be 81 x to the power of 5 and then y to the power of 12. So now we can expand it. So we bring that 4 as our denominator. So now we will get 81 with x to the power of 5 by 4 and then y to the power of 12 by 4. Now we simplify our exponents as much as possible. So we will end up with 81 x to the power of 5 by 4 and then y to the power of 3. And then we can also do, since this 4 is here, we can also apply it to the 81, and if that is possible, that would bring it down into 3 times 3 times 3 times 3 is equal to 81. So you take one of those, so this would become into 3. And our new equation would look like 3x to the power of 5 by 4, y to the power of 3. Can that be simplified any further? No, it can't. And you can always bring that back into radical form, but all you would have to do is bring the denominator to the outside. So here's our final answer. Now for the final practice problem. We have 16 x to the power of 1 by 3 y whole square, and then to the power of half. So what we would do is we just apply that. We would apply that power, so it'll become 16 x to the power of 1 by 6 y to the power of 1 half. So this would be the final answer. That last example is pretty easy. So let's just review the steps. The first step would be to expand your radical as much as possible. And once you expand your radical, you see if you can simplify any exponents, such as 12 by 4, 6 by 3. Those are all simplifiable. And then you would, if there's a fraction in your exponent, you can take it back into radical form. And you should also apply it to this outside value here. So you want to be careful of that outside value. So thank you for watching this video. Be sure to like and subscribe and watch out for future videos.